Hello, my name is Nigel Griffiths. I work in advanced technology support in Europe. In this part 3 of PowerVC 131, we'll be looking at the Cloud Edition. This is available for the PowerVM hosts, not the PowerKVM hosts. So we are talking about the Cloud PowerVC Manager Edition. As we saw in part 1, there's a slight increase in price when you go from the Standard Edition to the Cloud Edition, so don't forget that. Now, to give it its full title, it's the IBM Cloud Power Virtualization Center Manager Edition, a 7-letter abbreviation, quite a mouthful. And as an English person speaking in English, only 2 spelling mistakes. But what people are really calling it is the PowerVC Cloud Edition, or us techies are anyway. So in part 1 of this set, we looked through the things in green at the top in here, and these are available in the Standard Edition and in the Cloud Edition. The Cloud Edition, of course, is a superset. Also, in the Standard Edition are the projects and user roles, but they really only make sense, as far as I can see, when we're actually using the Cloud Edition. So please make sure you've watched that second video before you come here, otherwise you're not going to make a lot of sense to a lot of things we're talking about. In the Cloud PowerVC Manager Edition, then we have these self-service roles. We'll look at that in a second. We have the deployment templates, and the self-service guys can only use a deployment template in their projects. Then we look at the way we control with policies, the admin approval or not of the creation of a virtual machine or the deletion of a virtual machine with the VM expirations. We're not going to cover in this one the metering data that's available. I'm working on a worked example of that, and that may be in a later movie. As I've been using the Cloud Edition features, I've noticed some of them are like mandatory. You really have to get the hang of this and use it. Some of them you could postpone or take up later on when you want to use them. Now, the self-service user role is very important. That's what the cloud is all about. The users of the cloud can request resources, and they are managed by the projects and user roles. We've covered that in the previous video. That's really mandatory to understand that and plan for that from day one. Now, when a self-service user creates a virtual machine, deploys it, you can set it up so that the administrator user can allow or deny that operation, or you can let it happen automatically. And the same thing with expiration dates. So you can set it so that after a certain amount of period, the virtual machine will be automatically deleted unless the user extends the time that the virtual machine is made available to them. And again, the admin user can allow or deny those operations. Those 2 things in grey there are optional, and I probably think you want to have some sort of default policy as you start, and they're controlled by that power-cloud-config command. So that's sort of mandatory to get the hang of that command and see what the options are. The next thing is we have these things called deploy templates, and this is what the self-service user actually uses when they're requesting a virtual machine. Remember, this is meant to be a simplified, I'm not sure quite how we can say it, an IT challenged user, doesn't understand computers that much. So what we have is we merge a deploy image, which is the piece of disk that we'll clone to create the virtual machine. That should have your operating system, IBM X, Linux, Red Hat, SUSE, Ubuntu, and any software that you want as your default install. Perhaps you have a database, a web server, a blockchain, maybe you have security packages, or you have backup mechanisms all pre-installed so that when it rolls out it's ready to go and make good use of it fairly soon afterwards. So we take that image and we combine it with a compute template, and this has all the techie stuff. This is the number of CPUs, the amount of memory, any other disks that you want, any other settings on the compute things, the sort of things we have on the HMC for all the different options, and some of the new ones like the active memory expansion options for AIX. So we merge those 2 complicated things and we call it a deploy template, and the self-service user just sees that template and they can click on that and say, yes, I want one. Or you can have 10 or 15, maybe more deploy templates, maybe a small, medium, and large database, a small, medium, large web server, and they can just select what they want off that list without it asking them any complicated questions because they don't know the answers. Now, at the moment, every project needs its own deploy image, its own piece of disk that will be used to clone, and we should be regarding this release in June 2016 as sort of phase 1. There's a phase 2 coming out at the end of the year, where some of these things will not be a little crude, shall we say. So currently they're not shared, these deploy images. It would be nice, and I think it will be in the future, that we'll have one master image of an AIX with a database with our packages set up, and then all of the projects can use that one image. At the moment, you have to manually clone that image yourself and then put the different copies of the clone into each of your project. But it's quite simple to do, and it's not a problem. The last one down there is metering of usage stats. We can monitor things like the CPU, memory, and disks that particular projects or particular users are doing. The interface is the REST API, and it's pretty difficult to use, and so I'll save that up for a separate movie. Right, let's go and have a look at a self-service user so we can understand what that's all about, and then we'll come back and have a look at how we set that up. So we're going to log in as this user called Humble. They're humble because they're only the self-service user, but they do have access to a number of projects. So Humble is logged in as a project 6. We have here a bunch of virtual machines. These don't look like host names in particular because they're more to do with what the user is expecting. We can see the actual IP address that's been allocated. I've got an address range, and you can see them slowly going up in here, and we have an expiration date. In here, they're all active, but if I select on one, this self-service user can stop them, restart them, delete them, capture, and do the editing of the expiration date, ask for it to be longer. Notice if we do a capture in here, because we don't see images, we only see these deployed templates. When it captures the image, it disappears from this user's point of view. Right, well, let's select one. Let's go for the nice small one. These are on a very small machine, so it's we can run out of CPU and memory and things on here, and we'll do a deploy operation. Now, if we're deploying an image, of course, we get loads and loads of questions about what machines do we want it on, what sort of settings do we want to edit the processors and the memory, all sorts of options in here. This is for simple users, not IT aware users, so they're going to give it a name. That's the name of the deploy template to start off with. That's not a good example, so let's make it something obvious in here so I know what's going on later on. I haven't played with a number of instances. I'm a little bit worried that you could have lots and lots of them in here. And then in here we have description in here, but whatever you want to put in here, the purpose of the virtual machine, who's in charge of it, why they're doing this, maybe some project codes, I don't know. And we just click the deploy option. And it's actually done it. It's actually requested that option. I've set it up so the administrator user needs to allow it or deny it. And we can see up here we have requests. If we click there, there's this little yellow up number on here. There's one pending, so we're waiting for the admin guy to do this. And we've seen some deploys failed, and we've seen one denied in here, but a whole bunch of them completed. Okay, so that's what the self-service is about. They can click on things in here to look at creating particular images. These are named after the operating system. Typically these might be, standard platform version 29, small, medium, large, or database server, small, medium, large, and they can select the ones they want. They can see the operating system in here, the number of processors and the amount of memory. I've put in the description some more details about that, but in here you may have in the description, the details of the stack. This is DB2 version 9.9, and it's got the software package 28B or something in here, and so they can see more details about what they'll get when they ask for one of these to be deployed. Right, now let's go back and find out how we actually do this as the administrator. A few other comments before we carry on. I tend to crash and burn my PowerVC host because I use beta versions and I can't then upgrade to my the official versions. So I tend to go around looking for all my HMCs, picking up all the host machines connected to them, finding my virtual machines, the ones that I created with PowerVC earlier on, pull those into PowerVC, and then look through the disks to find the images so that I can create new virtual machines. And then if I start looking around for the cloud and the project stuff, then you find, well, everything is in the IBM default project, and there's nothing left for the cloud to actually start managing. And to put something into a different project, you actually have to take them out of the Power default project and then put them into the right project. And that's not the way you should be going about that. So you need to plan about some of your projects earlier on. Now in my computer room I have an equal mixture of Power 6, 7 and 8 computers, and so it was fairly natural for me to partition my group of servers into 3 different projects of Power 6, 7 and 8. Now in your computer room may be completely different. This is not like a general way of doing things in your computer room. Typically you'd want to have your machines in a particular project to be roughly the same sort of size. Quite nice, my Power 6 machines are all fairly small, but they're all absolutely identical, so it's a good way of operating a typical computer room. In my Power 7 case I've got from 710s to 780s, so quite a diverse range of computers, which is sort of unnatural way of running with PowerVC. It'll work, but what you want to do is to get PowerVC to manage a group of machines as an equal pack of machines. You don't have a favorite machine or want it to do load leveling across the group of machines that are fairly similar. So I decided anyway, this is where I was going to do it. I'm going to have project 6, 7 and 8, and then we have the IBM default will have practically nothing in it. And then I thought I'd create some users, and of course if I start calling them John and Jane or whatever, I'm forever forgetting who is which in which project and what role they have. So I've got sort of organized. We have 6 admin, 7 admin, 8 admin. I've got a deployer in here called half dozen. I then thought, oh, there's some girl and boy names for the self-service users called Sixtus and Sixtine. And then I created a user called Humble. We've already seen him, who has access as the self-service user on all 3 projects. Then I did 7, and then I couldn't find any first names with starting with 7 or 8, but there we go. This is what I've got, and we're going to be looking at the project 6 in detail. Now in part 2 of this series we looked at how to create projects and user roles, and I'm not going to cover that in detail here. We created the users at the Linux level and set them up with a password. Then we used once for every project an OpenStack project create description and give it a project name, and then we assigned the users particular roles on particular projects with the OpenStack role add, then the project username and the role we actually want to give them. And I'm not going to sit here in a video and type all those things at you. It's fairly mind-numbing, and you want to put them into a shell script really and just let it roll through and get them all right first time. Just to highlight once again that users can have multiple roles on a project and even access to multiple projects if you want to set them up that way. Right, now we can see the OpenStack commands in here. We can list the projects, the roles, and the users. There's a couple of roles that we shouldn't be playing with. They're sort of internal ones, so we'll ignore those. But then I thought, well, hang on, I've just created 20 combinations of projects, users, and roles, and I'd just like to see if they're actually the way I wanted them set up, and make sure I got them right. And if you run the OpenStack role assignment list, you get all those hexadecimal numbers. I mean, 64 bytes of user ID is not very helpful, but there is an option that I came across later on after I started trying to decode all these things. If you use the minus names, then instead of the IDs you'll actually get the names in there. That's good. And then you actually want to strip out a few other things in there that you don't want to see, and I've got a worked example on the next slide. So here's my OpenStack role assignment list command. I'm using the -c in here to give me particular columns of data. You don't get them in this order, but at least it will remove some things I don't really care about. Then we've got the minus names in here, so we get rid of the hexadecimal. And if we use the -f value, that removes these funny text boxes around the outside of the output. I personally think they're ghastly, but that's the way it's done. Now there are some things in here that we don't really care about. There's a thing called service. I forget if it's a user or a role, and it puts a default at the end of loads of things. This is the default domain name, it's called default. And so we just remove those from the output. So we use awk to give us the output in nice columns and reorder them so they help us look up the data. And what we end up with is output like this. So for project 8 we can see the admin roles and who it is. Then we can see the deployer and self-service and whatever they are down here. Here's my 6 with admin PowerVC user, has admin access everywhere. Then we have the 6 administrator himself, half dozen Humble, and the Sixtus and Sixtine. If you want to look at it the other way, user looking up a particular user and what they're allowed to do, then you can just reorder the columns in Orc at the bottom there. So this lets you do a quick audit. Have I got them set up the way I thought I was setting them up before we proceed to actually start using our projects? So we're happy now that we've got the project users and roles set up, and we're going to move on to some cloud settings, and we're going to use two different commands to do that. The first one is powervc-config command. This is particularly awkward to use. In the past we had separate commands to set particular different things. Now they're being all merged into one command. I like that idea. It's actually pretty difficult to use because it uses a whole set of sub-commands, and if you run the command -help, it only tells you these sub-commands are available, and you have to rerun it for every single sub-command to find out what it can actually do for you. But anyway, this is explained in my Expert blog, and it's now also in the Redbook, so you can actually see what's going on and what's possible on one page for this command. Some of the things we've seen in here before, the use of web timeouts is quite nice if you get fed up with it logging you out all the time, and the default domains for your virtual machines, it's now a sub-command of this command. Also for the Cloud Edition, there's some metering options in here, and we'll look at those in a later video. Next up then is the powervc cloud-config command. This is even more painful to use. This allows you to do the settings for self-service, for example, when they do a deploy, and do they need the admin person to approve it or not. The same thing with expiration dates, how far out they can push those and if they're switched on at all. And the number of captured images is important too. There's a note in here in the middle that if you don't set the expiration date options, then they don't appear in the graphical user interface. So if you're wondering why everybody talks about expiration dates and you can't see them on the screen, then that's why you have to go and actually use this command to put up the initial setting so that the expiration dates are switched on. So very briefly, with my own shorthand reminders of what these all mean, this is what we've got in here. The first one then is the default wait time for a deploy. This means that typically you may set it to like a week or something. If the approver, the admin person, doesn't approve it within that time frame, it will just automatically get approved. If, for example, your admin guy is lazy or negligent or goes on a holiday, well, you still want some business going on in here and virtual machines to be created. We have also an approval limit so that the self-service users can't go requesting hundreds and hundreds of virtual machines. The next three are the expiration, the default expiration days. Once you set this switches on the expiration, and you want to think long term. Maybe your users will want the virtual machines for 3 months or a year or something as the default, how long they get it for. Then we have the extensions, so that perhaps you want them to add 3 months extension every time once they had their first year, as an example. And then the third one on the list here, expiration resource timeout. I think that means that if it's actually expired, it becomes unavailable to the user, and then they may say, oh no, we forgot to change the ask for approval for some extra time, and they can quickly go in and get that without the virtual machine actually being deleted. The bottom one is we can do as a self-service user, you can do a capture of your virtual machine. Maybe you have it at a particular release and they have gone and upgraded the software or the setup or something, and they want it recaptured, so this is the new master image, so they can do a capture. And again, this number is to stop them running away doing tens or hundreds or thousands of capture images and using up your disk space. If it goes over the limit, then the administrators will be asked to confirm that this is going to go ahead. Now you have to decide your own policies for this. I mean, it's not too complicated, there's not many of them, but you need to think about that in advance. Maybe check that with your user community. Is this okay? Up the top there, of course, it says you need those PowerVC RC shell variables set, all those 17 or 18 of them, like when we're using the OpenStack commands to controlling projects and roles. So when you actually come to do this, I strongly recommend you do it in a script. And there's some real gotchas in here that I don't think are particularly pleasant. If you have in those settings your OS tenant name is IBM default, then even though it says Project 6 in here, this is ignored and it goes for the one in your environment variables. So you think you're setting Project 6 and you just overwrote the values for the IBM default project. So this is why I've got this unset OS tenant's name at the top in here, so that then the project name, as in supplied by the command, actually overrides the preference. So it best put this into a nice big shell script and get them right first time. A few more things you need to understand. Here we have Project 6. The 6 admin user has admin rights to all of the 6 projects, so they can see the servers, the networks, the volumes, the virtual disks, the image, the virtual disks that we clone to create virtual machines, and all the virtual machines and the compute templates, a whole bunch of other things too. The admin user will then select an image and a compute template, and that creates these deploy templates. So that's everything you need to actually do a deploy with no complicated questions. You give it a name and a description, and off we go. So those are then handed to all the self-service users. Each of the self-service users of a particular project can see all of the templates. There's no finer demarcation in here. And in this case, the humble users created 3 virtual machines, and the other users have created their own virtual machines, but there's a brick wall between them, so the self-service users can only see their virtual machines. They can't see anybody else's, which is quite a nice feature. Self-service users can't see the servers, networks, disks, and images. We've seen that already. And the self-service users can only see the deployed templates and their virtual machines. Now, if Humble does a capture of a virtual machine, maybe they updated it to a new service pack and they say that I want that as a new deployed template, well, they can't create that. They can only create a capture which creates an image which they can't see. Only at the top in here, the sysadmin user can see this new image. We'll need the sysadmin user to create their image with a compute template and create a new deploy template, and then the users can use the newer version of that template to actually create new virtual machines. Now, as the next demo lasted about 15 minutes, I decided to make it part 4 of this series. If you feel you've learned something with this video, please click the like button below. And finally, I'll leave you with my usual advert. I'm Mr. nmon on Twitter. YouTube.com nigelargriffiths is where you'll find all the other movies. Don't forget my AXpert blog, where I make regular comments and some articles in there. And the virtual user groups I highly recommend, one for AIX, one for Power Systems.